Welcome back. Michael Wickerson at Wickerson Studios. Just moving on to the third very simple algorithm. I'm going to set it in the motion with a bake. I have a little oscillation engine that I use here. And just let me put that over the bake and I can show you what's happening. We'll set that to true and there you go. You're starting to produce some very interesting geometries that you're not making. And I actually used GitHub Copilot. Wasn't really necessary. That's what's happening is as you start using this, you could ignore kind of, ChatGPT will give you some ideas. Rhino documentation is probably the safest thing to start with and go to. I'm going to take that bake off because I'm just making coincident forms. But you can see my objects kind of rotating around here. My script is very simple. It is a closest point node. So you can go here and you can basically go into curve closest point and substitute it for here and you'd be fine. But the thing is, you lose a lot of control when you use those off-the-shelf objects. So I basically want a point, but I want to be able to control what that point is as it comes in. I want that numerical control. Whether I do these multiplications or not, it really doesn't matter. I only did that to put the oscillation through. But if you wanted to see how this script really is intended to work, pretty simple. Just hard code this in, get rid of these multiplication factors. You have a curve, and you have a point that will be on that curve wherever my other point is situated. So I have a script that outputs the input point, which I have XYZ control over, so that's easy. And it outputs a point on the curve using a very simple function. Now the curve has actually not been generated, which will get very interesting when we plug through here in the curve menu and move out of the point area, because we're literally done single point, multiple points, and closest point. Drape points will be interesting because I've been wanting to use drape and Grasshopper because I haven't been seeing it used yet, and I've gotten stuck on that a couple times with hops and ghpython nodes and things like that. But we'll see. But sooner or later we're going to get the lines, polylines, and freeform curves. But right now I'm still hard coding in a curve, and I just have a script that runs. Now the script itself is pretty simple. And I just went to ChatGPT, some Rhino documentation, some parametric camp, basically get the closest point on a curve from an input point. So create a double variable that will store the curve parameter in the closest point. So I generated that, just started T because I'm going to be using that. I don't need to input that, so you have the option to add it here as an input, but you basically just want a container, a variable to hold that. So that generated pretty simply, and of course we don't have to be looking at it in the C# node. We can be looking at it over here in Visual Studio Code, because as you know, as I get into this, I'll close this up, I have this grouped with the script Parasite node set to true. So anytime that I update this, I'm actually updating over here in Script Studio, Visual Script Studio. Then I want to create an input point. Pretty simple. My XYZ coordinates, it already knows to do that. I type the hard text, it types the tough work of POINT 3D. But you're learning how the script really nice. And then I've used from Rhino documentation and parametric camp, and not so much from ChatGPT or GitHub Copilot, because it would make some decisions on this. But basically I took the curve in. I wanted to find its closest point. It's a function that's actually in the documentation. It needs a point and it needs an out point. And I'm going to output that point T because that's what I was trying to make. So I wrote a little script that basically did that. Now I have a point container for the point at T on that curve. I also generated the distance so I could mark that, and then my outputs, just by typing the word outputs and just hitting tab and enter, I was able to output PT out, the point on the curve I called PT, and then T out is the parameter on the curve out, and D is the distance. And that is it. And then you have a pretty cool node that outside of the single point node and the multiple point node, you're scripting these very simple components that actually can generate some pretty wonderful geometries. So if I wanted to grab a curve and have a little bit more fun like this, and loop through like this, and do that, and then locate that curve, grab a couple of points, pull them up, twist them around a little bit, locate these bottom curves, maybe put them through a rotation like that. That curve can be input. This is like basic Grasshopper stuff that makes things fun. I am going to take that curve and I am going to internalize the data because I don't actually want anything. And there's my curve and there's my object. We can send it through its oscillation. We can check it here to see what the script's kind of, sort of going to look like as we jump around. But we're going to produce a pretty interesting geometry. So as I put that through, and once again, I'm probably going to want to put a multiplier back on there because of my scale. So you're really using numbers in a sense of scale. I'll use the 0 multiplier on my sine output coming from my engine. And I will use the, I'm just going to move my curve down, move my multiplier through. So you really are driving things just by number. And we're not doing any fancy functions, sine and cosine functions. Pretty simple. I think I plugged that one in. This is the sine and cosine added to one another, so not multiply or divided because I didn't want to hit a 0. And there you go. It is generating and it is running. And while it generates and runs, let's see what type of simple geometry we can output as meshes. And let's take the mesh to 3-sided, which should be fun, triangles. And that should be fine. And we will just take it over the bake and see what we end up generating. So kind of strange, but the reason it's not really that interesting of geometry, because your mind can handle this, you just have to play with it. I'm going to take that multiplier way up to 10, and take this multiplier way up to 10, I'm going to take this multiplier way up to 10, and now, as we generate, let's try that again. What a way to construct something geometrically fun. Know the numerical control. You can change the speed at which this is actually grasping and recording it. And I think I'm going to take it to pen and ink because I like pen and ink. And I can't imagine I would ever draw like this, but now it's being coincident and my curve itself is generating this nice script. So if you want to produce some interesting geometries and you can wrap your head around what's kind of happening here computationally, let GitHub Copilot or ChatGPT or someone else's tutorial, if they've done it for you, or somebody, if before you get in the Rhino documentation, play with it. And the other thing you do is actually you can toggle this on and off, which is why I kind of make this playful. Like my whole script is kind of like a little game. And so if I went in here and I wanted to consider baking some geometries, I could also make it much more rapid. So I could go in here and I could say, listen, I want to record an interval every 20 milliseconds. I want this thing cruising. And now as I go back in, a very simple node, like I said, could be substituted by, and this is what happens, is people say, well, why would I learn it if I could do it faster by hand? Why would I do it in Rhino, Grasshopper if I could do it in Rhino? Why would I do it computationally if I could do it in Grasshopper? Why would I use GitHub Copilot if I could script it from the Rhino? Well, it gets more and more powerful and more scripted, and you might not be able to keep up with it. So coexist with this tool, and here we go. We're going to generate some interesting geometries. Here we go. Nice, just at the rapid pace of what it's happening. If I don't want to record there, I don't have to. I can always say, okay, that was kind of a nice little iteration. Let's pull that aside. Let's try it again. Okay, we'll grab a little bit here, take there. Obviously, it's going to be similar, but I can choose when I'm actually baking and making geometries. And this is what I've actually used animations or finesse or playfulness, because as a physical sculptor, I've been doing this forever with real, expensive pieces of wood, expensive pieces of steel, but I may actually just want to come to understand and make some models this way. And like I said, you don't really need to be going into Visual Studio Code. You don't need the Parasite tool to link over. It shouldn't be hard to write a simple script like this, but you're going to find that learning the script off of the very basic tools that Rhino teaches you, curve and surface manipulation, by the time you fly through here and learn this and make it so you can bring in inputs and additional outputs and inputs from your nodes, you're not stuck just using these vanilla tools. And there is a happy balance between a complex script and a small script that does enough to give you the data to drive some cool geometries. So that said, stop streaming and stop recording.